Hey robot makers, hope you're having a good day so far. So do you want to know about the Lego Mindstorms Inventor Kit and how that stands up against our own SMARS robot? We've not covered Lego robots on the show before, so let's have a look how that compares. So this is the show for you then if that's interesting to you. Let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to the keynote. Do you see that subliminal message there? That's just something new I'm trying out there in between a few of the transitions. Okay, so yes, this is about Lego Mindstorms. So I've had this kit for about 6 months now. I think it must be. It might even be maybe Christmas area perhaps. So that'd make it 9 months, wouldn't it? So yes, the session goals for today. We'll have a look at the Lego Mindstorms Inventor Kit, how that compares to building your own 3D printed robot, such as the SMARS Robot. Obviously, the Lego Mindstorms kit is a commercial product, so it's going to have a bit more polish, and it's that I'm interested in sort of teasing out today. So let's have a look at the Lego Mindstorms Inventor Kit, and there's 5 different robots that you can build within there. We are going to look at some of the capabilities, the motors, the sensors, how they control it, the sounds, the programming hub, all that kind of good stuff. And we're going to do a bit of a comparison between that and SMARS as well. You'd be surprised maybe at some of the results that come out through there. And then we'll have a look at what we can learn from the Lego Mindstorms ecosystem. There's quite a few things I think we can tease out there too. So the 5 bots themselves. So we've got Charlie, Tricky, Blast, MVP and Jello. So Jello is the one that I've got on my desk at the moment. Jello is it's kind of a quadruped. And using one of the community projects that you can get within this app that I'll show you later, you can actually make it look like a robot dog. So that's quite fun too. So yes, all these 5 robots can be built using the same inventor kit. You can only build one robot at a time, which is quite different than the Lego, is it the Blast kit? The one I've got, which is the, I don't think it's called the Blast. What is it? It's the one that has the R2-D2 in it and two other robots. You can build them all at the same time, but you just have one control thing that kind of slides in between all of them. So this is just using the same couple of servos. I think there's 4 servos. There is the hub, which is the box. We'll have a look at that in a second. There is a color sensor, and there is also a distance sensor as well. So the Mindstorms Hub itself, this is the brains of the robot. So it has matrix lights on the top, just underneath the surface, so you can't see them when it's switched off. When you press on, you can sort of see that spring to life. So it's a 5x5 matrix. They seem to be just one color, like a white LED, so it's not multiple color. So it's very similar to what you would get on a microbit, for example. It has a built-in gyroscope and accelerometer, so it knows which orientation it is, up or down, left or right, that kind of thing. And it can feel if it's moving around. It has 6 connectors, 3 on each side for the motors and sensors. And it's quite intelligent. It knows what's plugged into each of them. So we'll have a look at that as well, and what that implies. It has a rechargeable battery pack. So some of these Lego robots, I think originally just had AA batteries that you put in there. I had the original, I had the EV3 robot kit, Mindstorms kit a while back. I actually sold that because I got a bit frustrated with the limitations of what you could do with it within that ecosystem. I probably should have held on to it in retrospect, but yeah, I kind of outgrew that one, and that's what led me on to 3D printing robots. So this has a Bluetooth and USB connections as well. So the USB connection is mainly to power it so you can charge it up, but the connection to the robot is via Bluetooth. And it has a Bluetooth button on there, so there's a little round button at the sort of left hand side there. You can click that, press that, and it will activate the Bluetooth on the device, and it'll start searching for connections from your computer. And it can be an Apple iPad, it can be a Samsung or whatever, Android tablet or mobile phone. It also has 2 control buttons as well. So there's like a left and a right button there, and then there is a middle button which is an LED button. So you can actually change the color of the ring that's on there, as well as pressing it to activate, and that's all programmable too. It does have some sound capabilities, though it does tend to be just a beep. And to purchase this individually, if you want to go to the Lego shop and buy this, it's about £160, so this is not cheap. You compare that to something like the M5 Stack, which has a colour screen on it, for example. You can do a lot more with that for the price. But this is an official Lego. It's very polished as a product, and for projects it's very useful, particularly because it's got the Lego connection, so you can plug everything into it and have it integral to your robot. So the motors, they call these EV3 motors, but when I looked for EV3 online just to get an image to find them, they came up with the old model. So the ones that are on here are very similar to this one that's on the screen, but the colouring is slightly different. So this is one of the Spike robots, I think it's called, but it's exactly the same servo there. So it actually has feedback, so it can force feedback and see how accurate it's turned the motor, and we'll have a look at that live on the app. It's about 240, 250 RPM, so it's very, very quick. It has a really good torque on it as well, so it's quite strong for the size of it, for the power of it. And it can also, it's got running torque and stall torque, so that's like, you know, it can hold its position. And it has this thing called Auto ID, so that's built into all of these different components we're going to look at today. And that means as we plug it into the hub knows which port it's plugged into, which is really smart. We can't do that with regular motors or servos or any kind of component. There must be an actual chip embedded within the servo that can talk, because when you plug these in and you've not used it for a while, maybe like I did this weekend, it actually says that your firmware on the servos and on the sensors needs updating. So the fact that it updates firmware must mean that this has got a chip embedded within it with some flash memory. So it must communicate what version it's on, for example. So to buy these individually, these are not cheap. These are £21, so that's quite expensive for a servo. If you think about how much it would cost to buy a similar kind of motor. Now, I was looking online just to do a comparison with SMARS to see how much would it cost for an N20 motor. Don't know if I've got any of them to hand, but they're the really small motors that we have in the SMARS robots. You can actually buy them for 4p online. There's shipping on top of that, but just by way of comparison, 4p, that's ridiculous. That was from AliExpress. I was looking at that earlier today. Sensors. So the distance sensor. So this is very similar to what we have on our SMARS robot, or possibly the Auto DIY, where we've got these distance rangefinders, and they use ultrasonic. This one, again, has a bit more polish to it. So as well as having, you know, quite an accurate between 1 and 250 centimeters, it's also got 4 LEDs. We'll have a look at those. It's got kind of 2 around the top of the eye. They are eyes, aren't they? And then 2 around the bottom of the eye. And it's accurate plus or minus 1 centimeter, which is about what we would expect from a rangefinder. So this also has the Auto ID built in. So when you plug this in, again, the hub understands that this is a rangefinder, distance sensor, and it can also detect which port it's plugged into. It just makes the whole process of building this quite straightforward. It also tells you if you've got it wrong as well when you're doing the build. So I have to apologise for having a quick swig of a drink there. I've had a cold this week, so just getting better. But I've got a bit of a dry throat going on. So sensors. So this has a colour sensor. Now, I've never come across a colour sensor before. This intrigued me because I thought, is this just a camera with a different name? But no, this is a colour sensor. It's a specific device. You can buy these on like Adafruit. I've got a whole range of these, quite affordable as well. And indeed, you can just see what colour is presented in front of the robot. So I've got an old 80s toy here. I don't think this is an official branded Rubik's Cube, given some of the strange colourings on here, but we'll try that out and see if it can detect the colours on that in a moment or two. So yes, it can measure the reflected light, so it has a ring of light that it can shine out, and it can therefore detect that light coming back in, and it can also give you a colour reading for each of the red, green and blue. I think it gives a value between like 0 and 100 in theory. I certainly could get it up to 50 or 60 when I was putting it really close to the sensor, and it's highly accurate. It's very good at detecting colours. And some of the interesting projects I've seen online with this actually involve a Rubik's Cube, and you can literally put this on this robot, and it will maneuver these things around using the colour sensor to read the values of each of the blocks, and then it can understand how to very quickly, in less than a second, solve the Rubik's Cube. So very, very cool. Like I said, I've not come across these before, so this was quite a novel thing. I might be getting a few of these myself to give it a go, but not the Lego ones, just regular ones that we can put in our own block. And this, again, has the Auto ID, so the EV3 software understands what it is and which port it's plugged into. So yeah, let's have a play with that in a moment or two. So if you like these videos, please give me a like, comment on the stream, whether you're watching on YouTube or whether you're watching on Facebook. This all helps tell the algorithm that you like this kind of content, and I should get more views from that. And if you've not already subscribed to the channel, then you should think about doing that too. And if I'll get to my next slide as well. I do a video every single Sunday evening, so that's usually around 7 o'clock Greenwich Mean Time. We're in Greenwich Mean Time +1 at the moment because we're in British summertime, but it's there or thereabouts if you're watching. And I usually post about a day before to restream.io, which is the site I use to sort of tell everything that I've got a stream going on. So if you're on Facebook, you're in my Small Robots group, or you're in the SMARS community, or you know me personally, then you'll get notification of that. If you're also on YouTube and you've subscribed to my channel and you've tick the little bell, you'll also get notified that this is going live on a Sunday as well. And I will also do a midweek video, and that's usually the Wednesday or Thursday or Friday if I'm not feeling very well. That's usually some smaller, less lengthy topic. Okay, so the Mindstorms app. So this kit comes with an app. Now, I do worry about this long term, because what does that mean, you know, in say 10 or 20 years time, when people are wanting to still play with their Lego robots? Are they really going to support this software for that long? That worries me a little bit. And all the build instructions, there's no paper-based build instructions for this. It's all completely via the app. So again, that's something that it gives this kind of a life cycle that's maybe a little bit worrying, but we'll see how that pans out. So for now, you can download this on macOS, you can download it on Windows 10, iOS, Android tablets. I don't think there's a Linux version of this. I might be wrong, but I don't think there is. But it's enough devices that most people should be able to use this, no problem. And there's more like downloadable content within the app when you open it up, so you can download more models, and there's quite a lot of fun things to do as well. It isn't just the instructions, they've kind of wrapped a story around a lot of these things too, so really, really nice. And what I like about it is that you get immediate feedback from all the sensors. So this is something I want to build myself. I want to have a kind of dashboard that shows me on my robot at any given moment what are all the readings from the sensors. And I want those readings to be accurate. So if I've got a servo and I've set that servo to like 90 degrees, I want the robot to tell me if it is actually 90 degrees, or is it 82, or is it 104? Is it actually accurate or not? And the Lego one does this. So they must have a like a rotary encoder or some kind of potentiometer at the back of their servo that can read the actual readings live as well as what's been sent to it. So they have a really nice polished user interface. We'll have a look at that in a minute as well. And they can also detect, as I've said before, what is on each port. That's a really nice thing. Some people have said that to me before about how could we do that with like an Arduino or Raspberry Pi Pico. How could you detect what's plugged into each pin? Now, there is no way to do that just by detecting what resistivity or whatever is through the pins. You need some kind of other device that has its own firmware that can communicate maybe over serial to a device like an Arduino or a Pico or an M5 stack or whatever you've got there, an ESP32, to actually say, I'm this device and this is what version I'm on, and send me commands, I'm ready to go. So that's something that we would have to build onto some of our servos, and it would obviously increase the complexity and also the cost of the build, but you have all these extra features if you do that. So hats off to Lego for thinking of that and building this into their products too. So there's lots of code projects to try with build along instructions. They've obviously designed this in a way that it's what's the word, it sort of builds on it, cumulative learning. So you build a small thing and then you build onto that and learn the code as you go. And the code that they have is both Blockly type code, and also they've now included Python in there as well. So that's quite cool that they've included Python. That's definitely the way the world is going from a programming perspective. And they've got a really good community section, a bit limited, but really good community section with add-on projects. And that's where I found this robot dog that I've got on my desk next to me, we'll have a look at in a minute. So Lego Mindstorms code block. So like I said, this is very similar to Blockly. It's a very simple interface. You've got a, what would you call it, the shelf on the left-hand side where you can click on the coloured different dots, and then each one of them opens up, and then you can select from that, is it a control, is it a sensor, is it a sound, is it a light, that kind of thing. It's very easy to build simple, small programs, but the code does become quite unmanageable the larger that gets. Now, I have been following a tutorial series on YouTube by Microsoft. They do Make Code, which is very similar to this, and it's for their arcade. I've got the where I've actually put it, the little Meowbit, which is a Microsoft Arcade compatible board. And they've built some pretty complicated games just using this Blockly-like interface, but it does get very complicated and you have to sort of collapse them down and sort of move them around the screen. It doesn't really lend itself to having lots of functions and having them organized visually, it does just get a visual mess after a while, and you have to sort of hunt around and be really clever with your naming conventions. Whereas obviously with code, that's quite a mature way of organizing your code, just having actual lines of code that you can control. But it does have some very polished features, so we're going to have a look at some of these now. So save slots is one of the first ones. I quite like the way that they do this. So code can be saved onto the robot itself, so you can turn off the Bluetooth and it will run this code. You can simply select from the top of the robot when it's switched on. You can sort of say which save slot you want to load from, and then you can press the button, the control button, and it will run that program. And there's a whole load of them that you can actually store. Or you can stream from the app directly. So this is more like the MicroPython approach, where you run the code, or you can save it as like main.py if you want it to run in the background. But I just like the way that they've got that download or streaming, and you've got the choices there as well. I do believe some people have had problems with saving as well, because I think those save slots, whatever the memory is on board, and I couldn't find that information very easily, whatever memory it has on the board, I mean flash storage rather than memory, they've obviously just divided that by a number of slots, and then each slot program has to be no larger than that. Otherwise, you would run out of memory at a certain point. So they've only been able to stream some programs rather than downloading them. So that was just an interesting limitation. And it's those little limitations like that that will drive us more towards building our own robot when we reach these limitations. So yeah, Lego Mindstorms code block, the matrix animation editor. This is awesome. So I really like this. So what they've what they enable you to do there is edit the LED matrix. So you can click on different pixels, you can increase or decrease the brightness of those pixels and save that as like a frame, and then you can have a whole bunch of frames to make an animation. And you can slow down or speed up that animation. You can then send that across, you can name it and so on. And they've got an entire library that they created already for you. So, this is really quite neat that they've done this, and I just like the way that the interface has been provided. You've got the editor or you've got the library. So again, just another example of polish that they've included on there. And another thing that the matrix animation can do, which I think is really cool, and it's really simple, is you can change the orientation of the matrix display. So you can just say, this is upside down, it's left, it's right, it's upright, it's the normal way. So I've got my SMARS robot here. If I just go to my overhead, because it doesn't seem to flicker as much on this one. Excuse me. And you can see there we've got an 8x8 matrix, so it's a little bit more than the Mindstorms robot, and I've had to manually give some code for each of those, and these are simply on or off. Now I could probably make them so that they have different brightnesses, and this is something that I would be really interested to do. Now if I accidentally put this on the wrong way around, it'd be great if I could just go in the code and just say change the orientation. So if I've got him like upside down like that, it'd be great if I could just, rather than having to sort of flip it over, just change in the code which orientation it is. And also you can see there on this one, the wire actually comes out the left hand side. Maybe I want it to be that way up when it's in the build. So it'd be good if we could actually just change the orientation. It'd be very simple to do in the code. That would be reasonably trivial for us to actually do in code. Again, I'm going to steal that. That's a really nice idea. Just another example of polish and maturity that they've been at this quite a while now. Now I was talking to a friend of mine that I worked with recently, Kieran, and he was saying that he actually did his degree dissertation on genetic programming, which is kind of a forerunner to machine learning and artificial intelligence. And he actually did Lego Mindstorms as one of part of the example of his work. So the fact that it's about 20 years old is quite impressive. That I think it's just under 20 years old. Is it 2005 the first Mindstorms kit came out? It might be slightly older than that, but maybe someone can look up that while I'm talking and see. So yes, that's another example there of polish and maturity of this platform. So the distance sensor, I also like the way that this distance sensor has 4 individually addressable LEDs. It's another example of polish, and this is what you do get with a commercial product. So they got the time, and they want to delight and surprise you, and that's an example of delight and surprise. I mean, why would you need to do that? Because you can, is the answer, isn't it? So I'm quite impressed with that. We'll have a play with that in a minute as well. Excuse me there. And Now this was like, this is interesting. Since I opened this at Christmas, they've included this feature recently. So they've now included on the Lego Mindstorms Hub Python. So this is not this is not MicroPython. This is full Python. It's very easy to use. The documentation, though, I found was basic. There's not very much explanation about how you use a lot of the library routines. It's just kind of provided like, here's how you grab a distance from the rangefinder, and then that's it. There's no more example code. They just give you one snapshot of that. So I'm sure they'll build that out over time, but it is quite basic. But to be fair, it is in beta. It's just an example, you know, gives them an excuse not to sort of fully finish the feature. It's also quite impressive to have a Python interpreter running on an iPad. I didn't know that. I didn't think Apple would allow that, actually. They're quite funny about other development environments on their iPad. So here we go. This is the battle of the bots then. So let's compare a couple of different attributes of each robot. So from a code perspective, Lego Mindstorms, that has Python and blocks, or Blockly blocks. SMARS has Python or MicroPython or Arduino, depending on which robot you've built. So if you've built, I've got the SMARS Robot here. This one has an Arduino, so obviously that's running Arduino, which is C++. If you have one of the SMARS robots that has the Raspberry Pi Pico on board, which is the quad here, that can run full Python. So, or C, we can choose. You could probably even run Forth or anything on that. You know, it's a full computer, full Linux computer. So you can, depending on which robot you've built, you can choose the language there. So you have a bit more flexibility because you built it yourself. That's what I'm kind of getting at there. Extensibility. So the Lego Mindstorms, yes, you can build your own robots with this using the Lego system, but it is limited and it's very expensive. I mean, we've seen some of the prices of those components individually there. They are not cheap. You know, if it's £20 for a servo, if you want to build a quad robot, that's at £80 right off the bat. You know, these SG90 servos that are in these kinds of robots are very cheap to buy. You can pick up a bunch of them for under £10, I think. So yeah, there's an order of magnitude of difference in price between these. So the SMARS robot is very extensible, definitely cheaper, but requires more effort, and you're not getting that polish when you build something yourself. So if you 3D printed something, the bits don't fit quite right, you might have to print them again, or you might have to sand off some of the parts. You'll not get that with a Lego product. Things will just work, and they'll work perfectly because they've really engineered that and they put a lot of effort into that, so they can repeat it and keep selling different ones. And our robots tend to be like a one-off model. Although the SMARS robot, I mean, these both use the same chassis. So underneath, these are the same robot chassis. They just have different purposes. They have different bits plugged into them. Cost. So yes, Lego Mindstorms, this one was £230. You might be able to buy it cheaper. I did hear that they were going end of life soon, but I mean, this one's not been on the shelves a year, so maybe that was old news. But I did see somewhere that they were looking at ending Lego Mindstorms completely in June 2021. So I don't know whether that is the case. They've certainly got it on the website still, and they are clearly working on code at the moment. The fact that this is in beta, for example. So I can't imagine they would drop that, but maybe it's a bit too expensive for schools to buy. I mean, if I was a school and I was looking at buying a number of kits because I've got a classroom full of kids and you want as many kids to have a hands-on experience as possible, £230 for, like, you know, class of 20, that's very expensive. Whereas if you wanted to build some DIY SMARS, you know, robots, it's just a couple of hours, maybe days, maybe weeks printing out some parts, but then it's very cheap to build a SMARS robot. So I think I totted up the cost. The 3D printing, well, the entire robot, is, I said there, is less than £20. It's about £18 is what I calculated. The expensive parts of that are mainly the Arduino and the motor shield, which sits on top. So this board that sits on top of the robot. And when I say expensive, it's relatively expensive. So an Arduino clone is about £3 or £4. The motor shield is again about £3 or £4. And then a couple of N20 motors. Maybe if you're in China, you can get them for 4p, but yeah, they cost me about £4, Adam. I was reading your comment before about that. So yeah, it's not very expensive. You only need 2 motors in there. You need a battery, a 9-volt battery. That's maybe £1. A battery connector, the little 9-volt connector that connects to the battery. Oh, thank you. Somebody's just bought me 3 coffees. Very, very kind. Thank you for that. So yes, if you buy the battery, that's about £1, another £1 maybe. I mean, you tend to buy these things in bulk, so I've got a whole load of battery connectors up there on my shelf, and it probably cost me about £2 to buy 10 of them, something like that. So they're very cheap. And then maybe some solder. And if you want some of the add-ons like the rangefinder, they're not very expensive at all. They're just another couple of pounds. So cost-wise, SMARS definitely beats the Lego Mindstorms hands down, unless you just like giving money away. So who these targets at? So the Lego Mindstorms is obviously targeted at beginners, whereas SMARS is beginners and intermediate, because the idea of this is that you build onto it and you can build it out. So this is a bit more of a challenging build, the quad robot. Let's just go full screen for a second. So this one has a lot more to it. I've got a camera built in there. We have the Raspberry Pi Raspberry Pi Zero, sorry. And then we have 8 servo motors on there with the feet. But this is a great build to make. Very interesting to make something walk as opposed to just move around. And then we have the much simpler SMARS Robot, but this one has the LED matrix on there. And the LED matrix, I've made that so you can actually program your own different faces and so on, and even animate them. I have an app that I built that I can press buttons on there and it'll animate the face. But I'll not run that now because that'll be a bit of a distraction. I've also got on here a Bluetooth module as well. These are not very expensive to buy. I've got a whole bunch of them. But it's very simple to build this up. This has even got the buzzer on there as well, so there's a lot going on there. Very simple to build, but you can just start with a very simple SMARS robot that just has the rangefinder, and I've got a whole row of them just next to my desk there. In fact, if I go to another shot, is it maybe this shot for a second? If I point over here, can you see there's a SMARS robot there? Not a very good shot, this, is it? Maybe if I move that out of the way. Well, you can take it for granted. I have a lot of SMARS robots on there. Another robot which is similar actually is the Auto DIY, and I hope very soon we'll have the inventor of this on the show doing an interview talking to us about this, and that runs on an Arduino Nano. And this one is a biped, so this has just got 4 feet on it, and again an interesting walking motion on there. So let's get back to our comparison. So audience-wise, yeah, intermediate. Yeah, I mean, Rich has made a fair point there about the cost, actually, just going back to that. You do need the 3D printer and you do need filament. Now, the filament element is very cheap compared to Lego. Lego is like ABS plastic, so I would probably use PLA plastic rather than ABS if I was 3D printing this, just because it's less fussy. But you do need like a £230 3D printer, but when you've got one, you can keep using it and keep printing on it. So you can probably just see on that shot there, which is my rear shot, is that no, not that one. Well, just over here, that's my Ender Pro 3, which you can just see sat there, and I've got a few other robots just to hand there. And you might need some other tools as well to design, you know, your 3D models in. So I use Fusion 360. I've got the paid version of that, but you can just use the hobbyist and educational license for free as well. So yes, the color detect, that's quite new. So Lego Mindstorms has that. I've not come across that before. So SMARS doesn't have that yet, but there's nothing stopping us from buying one of those and building it on the front. I mean, I'm thinking it can be another module similar to this, where we've got the color sensor on there. So that'll be something maybe that'll be in the works. Maybe I need to add that to my ideas list. Servos. So yes, the Lego Mindstorms kit comes with 4 servos. SMARS Robot, the quad robot, actually has 8, so we've got more servos on there. And to control the servos, if I just go to this for a second, we could actually have 16 servos on here. I've got the PCA 9685 board, which we've covered on this show quite a few times. Maybe I'll go to the overhead shot, is an easier one for us to see here. So if I hold this up here on the back, we've got a number of different connections there from all these different servos, and we've got a whole load of extra slots just here. So we can actually increase the number of servos on these things significantly. Whereas on the Mindstorms, you've only got 6 ports, so you can only maximum have 6 servos on there unless they have an extra thing. And Adam's saying that he's got a colour detection code for the M5 stack products. That's interesting. I'd be interested to see what you've got there and how that works. So the rangefinder, yes, we've got that on both of them. Though I do quite like the rangefinder they have on the Lego Mindstorms robot. Let's have a look at that for a second. So this this is the one that I built, and the rangefinder is actually just there. You can see it has the sort of sender and receiver, and we've got the color module just underneath there as well. And each of these big blocks here, they're the servos. They're quite huge. This head is entirely just for show. It doesn't actually do anything on there. Similar with the tail. And then that is the, I just press the on button there. That is the hub. So if I put this back underneath the overhead camera, you might be able to get a better shot at it there. So it's actually displaying an arrow at the moment. Can you see that there? So that's what the LEDs look like. They're just like yellowish colour, and we have the control button just there, which is currently flashing white. If I hold down the Bluetooth button, you can see that sort of flashing blue there as well. So it'll do that until it's found something. I'll just switch it off for now. We'll come back and do a bit of a demo in a second. So it does play some sounds, but they're not exposed through the Python interface, so I don't know how we would play that kind of sound through it. I'll say that there is an app function. We'll have a play with that in a second, actually, to see if we can get that to work. So this is the other thing as well. The app. So yes, Lego Mindstorms comes with an app, which we'll have a good look at in a minute. And it's a commercial product, so it's very polished, it's very finished, whereas our SMARS robot is completely our own custom code. So I did have a go at this a number of years ago. I created the SMARS lab, and the idea of that is it gives you a dashboard. You can control your quad robot by sort of pressing buttons on the screen, and you can access that from your phone or whatever. And that website essentially is running on the robot, and you just connect to it through the local Wi-Fi connection. So it's kind of like an app, but it's more of a web page, and it's certainly not finished. It's not a commercial product yet anyway. So that's the comparison. I don't know who you think would win in that. It is a bit of an unfair comparison because they are so different things, but I thought it was worth doing, worth exploring. So let's have a bit of a demo, shall we? I'll just load up the Lego Mindstorms app, and then I'll show you what this looks like. Okay, so if I come over here, so my face is just in the way. If I just press this for a second and then just zoom out a little bit, there we go. You can see there. This is the app when we launch it. So if I click on the home button there, this is what we look at, and we can hover over them. We can click on the individual robots. We can see what different steps we've got and other activities. So this is the robot that I built. I've just put the dog head on the top of it there. And you can see things like seeing red, hang tight, wrecking time, object detection. Now that's not really object detection, it's more a colour detection and using the rangefinder to walk up to something and then stopping once you've found that. But what I really want to show you on here, if I go back and I go to the code area and I press on this little button up here, which is the hub, it's going to ask me to switch on the hub. I'm going to go for the Bluetooth connection as well, actually. So I'm going to turn on the hub. So what I'm doing there is I'm just pressing that button there. Go for that for a second. So it's looking for a nearby hub. If I shrink this screen down, can you still see it? I'll just move that down a bit so we can see that there. Okay, so it's connected. The hub is now displaying that sort of play button. And what that play button enables me to do, I just move the camera over here for a second. If I press backwards and forwards on here, we'll just get that so the light is correct. Can you see how it's got these different numbered slots? They're the save slots. So I can either stream to the robot, which is what we'll do, or we can load, pre-saved program that we've put into one of the slots. So now that we've done that, we can close out that. Has it not detected it? Oh, maybe I need to just press that Bluetooth button. Let me just try that again. Just have to hold that down for a second. There we go. It's quite quick to find it once we've pressed that. Let's wait for it to find it. Obviously, I've cursed it now by saying that. It's quick. Come on. I'll probably just switch this off and switch this on again if that doesn't actually work, because it should have found it by now. Or I could alternatively just plug in a USB cable, but that seems like a bit of a cheat to me. Let's try that again. This is the issue with live live streaming. Things never quite work when you want them to first time. So I'm going to get a USB cable to hand if that doesn't work this one time. So let's press that again. There we go, connect. Right, press connect, it's found it. Okay, I want to connect to that device. Just came up with a message then. Okay, now this is what I was talking about before. Let me just go full screen. This is an example where each of those servos and all the other devices must have some firmware installed. I've actually updated all the motors already, so that's fine. But isn't that quite cool? That's quite awesome. So we've got another supporter. Thank you, Mariso, for joining that and buying me a coffee. That's very generous of you. Thank you for that. Thank you for supporting the show. So at the top of the screen over here, can you see these different? We've got 4 servos, we have a rangefinder, and we have a color sensor. And you can sort of shrink this, or you can enable this, and that's icon there is supposed to represent the hub. So if I put in front of this robot my hand, can you see now how that is changing? I'll try and keep it so it's there we go, 10, 7, 6, 5, 4. I'm practically touching the robot now, so about 4 centimeters seems to be the range. And then what I'm also going to do, let me get out the move this down here. So keep your eye on this color sensor here. I've got this Rubik's Cube and I've got the red face. I'm going to show it the red face and watch what happens to that as it gets within range. It's now saying red and it's got a number 9. If I move that to the yellow side, let's see that it's now changed to 7 and that's yellow. If I change that to the blue side, it's now number 4 and that's blue. Let's try green. It's now yet number 5 is green. So this can detect apparently 8 colours by name. So we can have a look at that in the code as well in a minute. Let's just switch off that for a second. And let's just try a couple more colours. So that's a purple. It doesn't recognise purple, but it does recognise this sort of pinkish colour being different, I think, than the red. Yeah, red is 9, and that sort of pinkish colour is 1. So there we go. It's not done too badly there. Okay, so let's go back full screen on this, and let me just move this up so we can see the whole thing. And what we'll try and do is, so it says when the program starts, an E must be the number of the letter of the port, so the 6 ports lettered A to F, and each of these ports you can just sort of toggle to say whether you are, there you go, A, B, C, E, D, F. This is what I mean about the polish. They've just got nice graphics and things. So you can select which of these you want it to connect to, but obviously it knows that rangefinder is connected to E because it's got some firmware and it talked when they booted up. You can set the orientation. You can set the orientation there. Oh, it's having a bit of a walk actually. Let's see what's going on there. It just went for a little bit of a walk then. I don't know why it decided to do that. Was it because I clicked something? So play sound initialization till done. Meow, what's cat meow? Let's try that. The sound did actually come out of the hub, so it clearly can play sounds. I'm just going to move that down so you can see a bit more of that. And so what it's going to do, this program, let's just have a look line by line. And then we'll look at some Python code as well. But when the program starts, so light up the top part of the eye and then the full eye. So if I move that around there, you can see that these two here, oops, these two are lit up. That top one is, but the bottom one there isn't. And it's going to play, it's going to set the orientation to whatever we want it to be right. I've set that there. Again, you can't quite see this just because of the camera lights, but there's like a strobing animation going on there. The animation is pulse. We've got a few different options there. We can go into the animation editor or we can go into the animation library. And then we've got play a sound. I've just chosen cat. And then it says Jello, set speed to 80, walk forwards. And what else have we got? If I just scroll the screen up there. It says, and then then walk for 3 seconds. So I'm just going to move the robot back so it's got somewhere to walk to. And then I'm going to run the code. And the way that we run the code, down at the bottom right here, there's a sort of stop button and a start button, and I've got it to streaming mode. So if I just press the play button now, now that sound came out of the computer, not the hub. So There we go, it's having a bit of a walk. I want to show you the walking motion on this because I was talking to a friend of mine that has, she collects Sony Aibo robots, and she was asking how many degrees of freedom this has. So each leg has 1 degree of freedom. It's not brilliant. So if I just hold this and show you the actual walk, that's the walking motion. So it's quite clever. The fact that it's got these different pivot points, so there's a pivot point there and a pivot point there. It's not very easy to actually show you how the servo itself, if I can just show you, that servo is the round bit just there. So as the robot moves, this bit is sort of turning round, and then it slides through that, just turn this over, it then slides through this area there. So this sort of slides backwards and forwards. So that's the code, and there's loads of different programs. We can have a bit more of an investigate on the app. So if we go over to there to lights, we can set all the different LED matrix lights. We can set the lights on the rangefinder. I'm quite jealous of that. I like the way that works. The sounds, I think that's a bit of a cheat because the sounds come out of the computer, not the actual robot itself. The program, when the program starts, you've got this sort of start block, and then you've got specific blocks to this model. So what they've done there is the walking motion, that sort of pattern of moving the servos in a particular sequence, that's a high level function that they've created because the servos themselves only know to go particular degrees. Now again, another thing that I quite like about the degrees on here, how do I get to that? Let me think about how I got to that last time. Was it on there? Yes, here we go. So I clicked on the hub button, and we can see there, here's the hub, here's all the different things that are connected to them, and you can actually express this as a power, so they're currently off, a speed, which it currently isn't working, a relative position, and the absolute position that it's in. And so each of these have got different, so this you can measure in centimeters. If I scroll down, there we go, so it's 200 centimeters. If I stick my hand there, this is real-time feedback. I can change that to be inches if you're American, you've got imperial, and I can have that again as a percentage. So how close is it as a percentage, which is an interesting way of describing that. And similar with the color, we can say what the color is, how much light is being reflected back. So if I stick my hand in front of that, we can see a certain amount of light is being reflected. If I put something that's shiny, it should reflect a lot more light. Maybe not too much there. Or you can have that as the actual name of the color that's there. So if we go back and say color, so if I stick that red Rubik's Cube there again, we can now see that the color that's being represented there is coming through. You can also look at the individual red, green and blue values. So if I go, so I've got my Rubik's Cube here, I'm going to put the red one in front of it, and we can see that we've got 80, 94, so it must be a value between 0 and 100. If I now change that to yellow and put that right in front of it, oh, that's gone to 150, so that means it's a much higher number than I actually thought. Change that to green, however, there's not much red being reflected off the green, similar with the blue. However, if I change that to blue, we've got a much higher value of blue because that's the face we're actually showing it there. So that's quite neat. And you can also see the rangefinder, which is right underneath that at the moment. These are oriented like so. So as I'm moving that towards the rangefinder or towards the colour sensor, you can see how that's working. Okay. So I'm just going to have another drink for a second. Okay, so let me just go back full screen on that so we can see what else we've got. And this has also got an accelerometer on board. So look at the pitch and the roll and the yaw. You can see all the 3 orientations. Again, if I just drag this down, as I'm sort of orienting, I can look and see which, what angle that's at from a degrees perspective. I can say orientation, and so that's the front orientation. If I put the robot on its side, it knows it's on its right side. I like that. If it's upside down, it's on its back. If it's on its top, or it's on its bottom, or on the left side, I think that's the last orientation that we've got. Yeah, so it knows exactly what orientation it's at. Gyro rate, we can see as we sort of wiggle this around, they change. And similar with the acceleration, as I sort of move this backwards and forwards, it can see the acceleration. Sorry, click on that acceleration again there. We can see that sort of change depending on which of the orientations you're moving the most. Okay, let's get back over here, back to the full screen. So that's an example of what the hub can do, and I love that. I think that's a really cool thing. That's something I want to steal for our robots. So sound, yeah, I think that's a bit of a cheat because the actual meow isn't coming out of the robot itself. There are other blocks that we can add to this, so we can add motors, more movement. They've got this thing called Lego Power Up, or Powered Up, which is just motors. So rather than it being a servo, it's just a cheaper component. I think it's cheaper, and it's just a motor. And then you've got some experimental ones. Xbox controller, and I was thinking, ooh, that sounds good. How could we do that with a SMARS robot? How could we make an Xbox remote control, either through Python or Arduino? I've not looked for any code on that yet, but I'm pretty sure that has been done. So that's something we're going to look at as well for the SMARS robot, I think, for the future too. So if we look at more motors, more movement, more sensors, music. Music should be pretty straightforward to add to it as well. I don't see them appearing in the blocks though. So I'm not sure why they've not appeared. Maybe I need to stop that. No. So I don't know why they've not appeared there. I would have thought they would appear after I've clicked them. Anyway, let's go to another project. So you can write code in Python. So I'll just show you how we do this first before we get back to that. I think it's trying to stream it to the device there. So let me just bring up. There's a console as well that we can load. I think what I might do is just quit this and start it again because it does seem to have not kept up with me. Some of these elements are working, but some of them don't seem to be working. So let's just try that again. Yeah, that doesn't seem to be actually working properly. So what I'm going to do, I'm just going to quit the app and then just start that again. It doesn't take a second. I can hear it ticking as it's just sort of saying that it's disconnected. And as I run it again, I think it does connect quite quickly. So let's just do that. Back to the code. Make sure we're connected to the hub by Bluetooth. I just need to press that little button again. Let it find it, and then we can connect. There we go, connect. Much quicker that time. We got a little chirp to say that it's working. Ah, there we go. We've got a lot more things appeared now on the blocks as well. So again, we can set some of these animations. We can set the brightnesses, the rotation, sound. We've looked at that. You can play a beep. You can stop and start sounds. I think that's for doing like different pitches. And then they have got a music section somewhere where you can drop in some melodies that you've created as well. And then they've got the usual kind of control blocks or repeating, if loops, for loops, and the sensors themselves. So if the color is a particular color or the distance. Now the other thing they've got is gestures. I think these are quite neat, and that you can actually record a gesture, and it's to do with the accelerometer and the gyroscopes, and it records over a period of seconds what they've changed to. Now I don't know how it would know that that's a specific gesture. It must apply some maybe machine learning on that to say that, you know, if you shake something, it knows that that's a shake, and therefore if you shake it again, it can detect that. So that's something that I'll explore. We then got all the regular kind of operators, variables, and my blocks as well. So if I go back to the home there and projects, we want to create a new project, and we want that project to be a Python project. So when I click plus, it can either be a word blocks as they call it, or it can be a Python, which is in beta. So let's try that. So it's immediately opened up, and apologies if this is quite small for you to read, but it's got from Mindstorms import MS Hub, which is Mindstorms Hub, motor pair, color sensor, distance sensor, and app. And then from mindstorms.control, so that's like a subset, import wait for seconds, wait until, and timer. So I don't know why they haven't just used the regular Python timer or sleep function there. That seems to be something that they've specifically done. Then they've got mindstorms.operator, so you can import greater than, less than, equal to. Again, I don't know why they've sort of reinvented the wheel there, and they've got a maths function as well, a maths library as well. So let's try out some of the code. Now, just where my head is over here, there's a little book. If I click on that book, if I just move my head out the way for a second, we can see that there is different libraries. So if we click on the Python, we can see there is a hub. So if we click on that, we can see there we've got Mindstorms, import MS Hub, and then the example is hub equals MS Hub, which they've already provided there. So that's not great help. Let's try let's try status light. So you can change the status light to be on. And again, they've given an example there. So we could write our own piece of code that says hub.status light. And the autocomplete isn't great on this either. It doesn't seem to pick up everything. It'd be nice if they use sort of VS Code and you could just import these libraries that way. And yeah, there we go. So let's try that. If I run that code now just by pressing that button there, let's go to the overhead to see, does that button there appear to be blue? And yes, it's blue. Can you see there it's sort of flashing between red, or amber coloured, and blue. So if I stop the program there, and let's go back to the code. Let's try another couple of examples. So we've got motors, sensors. Let's do the color sensor. So on the color sensor, we can say color equals get color. I think it's hub dot. No, it's color sensor. Sorry, color equals, get ahead of myself here, color sensor. There we go. So that's the kind of sensor that we're working with. We have to tell it what letter of the hub we're working to. Remember, they have like A to F, so this is connected to E. I'm not sure it actually is connected to E. I think this is connected to F. So let's just change that to F. So that just creates the class, the object. So what we now need to do is color is, and then color dot get color, and then we can say print color. I'm spelling this American and it grates on me, but whatever. It's one less character to type. Color is, because obviously British, we have a U in color. And let's just have a little loop here that says while true. And then I'm trying out the different keys. If I do command and the square bracket, I can indent code as well, which is nice. Okay, so let's run that. What I want it to do then is just print to the console what the color is that it's seeing. So if I open up that color, so currently is none. I'm going to stick the let me just go to that. I'm going to stick the yellow one in front of it, and let's see what happens. It says yellow. Now, that's quite neat, isn't it? If I now change that to be red, it now says red. If I now change that to be blue, cyan, which is blue. Cyan reminds me of ZX Spectrums. They used to have cyan and magenta, so that was like a magenta color, and that's more of a blue than it is cyan. Cyan to me, I've not got any cyan colored things to hand really. It's more of a much lighter blue than that. We try green. Yep, green. What's that color? That violet. It recognizes violet. Does it recognize purple? It does not recognize purple. It should recognize black. I don't know if it recognizes this sort of turquoisey color. No, it did recognize black for a second then. This is black, but it's shiny black. I don't know if that's gonna. No. Because black is the absence of colour. I don't know how it would detect that. And then this is red. Red. There we go. Now the other thing it comes with as well is a red ball. This is very Aibo-like. If you've ever seen the Aibo robot from Sony, that comes with a red ball as well. Part of the build is also a little bone for the robot and some food in a little food bowl. Again, that's just very cute. Cool. Okay, so let's get back to some code over here so we can just stop that from running now. So I'm loving that they've opened this out to Python. I think that's like a real advantage that they've enabled us to do this. But like I said, the documentation, it's a bit weird in this. I mean, you can open it up full screen by clicking there, but it's a bit weird how it, again, it's not really full screen, is it? It's kind of trapped in this, whatever this documentation tool is that they've got here. So it's not great, but it is in beta, so I'll let them off for that. So let's have a look at some of the comments people have been making. I can see you've had quite a few different comments there. Is there anything else you'd like me to try out while we're still on the stream? If so, let me know it in the comments, and we'll try and do that. So let me just back up on the comments there, because people have been talking quite a bit there. Okay, so first of all, hello Abdi, thank you for joining. So I can see you're a new subscriber, and thanks for saying that you enjoy the content. That really does matter to me. That's why I do this. So you're getting a welcome from all the other members there. So Adam was saying Mindstorms used to allow external hardware development. So I think they're certainly opening that up. There is a lot more community aspect to this, but obviously they want to sell Lego, don't they? So they've got to make it a better offering than what you could do on, I guess, 3D printers and the, you know, the availability and the cheapness of parts has really threatened this whole robots thing. And maybe they're thinking, is this something they want to keep investing in? Because it's quite an expensive thing for them to do, as well as to, you know, how many units do they expect to sell at this kind of price range? And Tom was saying there wasn't a firmware which you could use something like blocks for SMARS as well. I thought you made a video about that. So there is Scratch. You can connect Scratch to SMARS in a kind of roundabout way, but there isn't anything. See, one of the challenges that we have, I quite like Python as a language. I find that very easy to read and write. And for beginners, it's a much easier thing to grasp because it's more like English. There's just the indentation, which actually makes the code easier to read as well, I would argue. Whereas with Arduino and C++, you've got a lot of like heavy computer science things within that some people who are new to it just haven't got a clue. So just having the word void in front of every single function, I mean, why void? It just doesn't lend itself to explaining itself, and having been really strongly typed as well. Yeah, every single variable has to have a type before it and has to be declared before you use it. That kind of stuff doesn't lend itself to just sort of quickly hacking code together for a beginner. So for more seasoned people, having strongly typed code is really good because it means your code is more reliable, and you know, you're informing the compiler what you want to do and your intent there. Whereas if you don't, with, you know, less strongly typed languages like Python, then that can lead to some weird bugs that you don't expect. So yes, bit of a tangent there, but yeah, what I'm getting at there is, so what I would like to see with SMARS is that we have like a Blockly type block language that you can then press the drop down button and then it be Python or JavaScript or whatever other language you want. That's the ultimate goal. Now McAleer has done that for the Auto DIY. They have an entire version of Blockly that they've developed, and they can do all kinds of fancy things with this. And this runs just on an Arduino Nano, so it's pretty accessible. So I'd like that to do that too. So Adam says there's a big problem with Mindstorms. It started out about £100 a set, and then they broke £200 a set, which is way out the average person's budget. Completely agree, Adam, and I think that's one of the reasons why people do look when they're getting started with robotics. Is this something a bit more accessible price-wise? Because, you know, this is an expensive toy to buy, because once you've done all the different kits and everything with it, you know, other than buying even more expensive servos at £20 a go, it's not really lending itself. And they're physically quite big as well. If you compare the size of these things, one of their servos is absolutely vast. I mean, you know, if you think this, I'm trying to show you, like, the size of the servos on this are absolutely minute. They fit within that little square there. Whereas this thing, they're absolutely huge. That's the servo. It's massive. You know, one of their servos is like the length of a SMARS robot. So, and that's what I like about these small robots. That's why I'm passionate about small robots. They're really accessible to people. They're very cheap to buy. I mean, a SMARS robot, less than £20, similar with a Auto DIY. I think their kits are actually a bit more expensive, but they put a lot more into that. It's a bit more polished. So, but I completely agree with you there, Adam. I think £200 plus for a robot kit is quite a blocker. And it's damaging Lego as well, because they're not able to sell as many kits for that kind of price either. So Richard's saying, I think the cost is a bit unfair because you do need a 3D printer, tools, expert in design time, and so on. I mean, yeah, you need time with Lego as well. I mean, it took me basically all of Saturday to construct this from all the different bits. So, you know, that wasn't quicker to put together. It actually took longer. With a 3D printed robot, you know, the number of parts that you're constructing is quite small, really, but you just have to wait for the thing to actually print out. That's where the real time suck is there. And designing it, You can just go onto places like Thingiverse and download the already designed parts. That's how I got into SMARS. I was looking for a small 3D printable robot, and I came across the SMARS robot, and my passion for SMARS sort of grew from there, really. And Tom's sort of in violent agreement with you there as well. And Adam says, yes, you need tools, but you also need access to a printer and design software. Fusion 360 is free for beginners, and there are other software tools out there as well. There are things like FreeCAD and is it SketchUp? Not sure if that's quite the same, but yeah. After you give them info for it, yeah. So you do have to renew your license with AutoCAD each year for Fusion 360, but it's well worth it. You pretty much get the full commercial product. There's only a few things that you can't get. I think some of the rendering stuff you can only do on your device. You can't send it to the cloud, but to be honest, I've got the full version, and you only get so many credits, and once you've used them, you lose them. And Adam says, yes, 3D printers, ABS is toxic, and it is definitely a pain as well. I think that's why I prefer PLA plastic as well. So all my 3D printed robots are a PLA. So it does mean that over time they do rust, they do sort of get brittle. So my InMove robot, which is just above my shoulder there, I printed that over about 2 years ago, and it's now beginning to show a bit of signs of, it's quite brittle now. If I drop that, it just shatters. That has happened once. Whereas ABS will last, it will outlast you and your children and your children's children. It will be around forever. If you throw PLA into the sea, it will actually rust and degrade to fish food within 5 years. So it's completely biodegradable, made out of fructose. So it's actually made of like sugar. And username, password, and email. Yes, you need to provide all those different things for Fusion. That's what we're talking about there. And foot versus Lego, Lego always wins. That's very true. If you've ever walked across a carpet with a hidden piece of Lego in there, it's like walking on an upturned plug socket. It's very, very painful. And Tom says, from my perspective, there's a colour detect module for SMARS. Is there? I'm not sure. I bet you're right. I bet you're not wrong. I mean, I've always thought, why not just go straight to a camera? For the cost of a camera, I mean, one of those cameras, I mean, the ESP32 doesn't cost that much. And that's like a camera module. I've got one. We did that entire video on it last week. I'm sure I had some to hand here. No, I must have put them over there. So I've got some ESP32 cameras, and they cost less than the actual Adafruit colour module. And you can detect what colour it is from that just by looking through it. It just requires a bit more processing and a bit more code maybe. But you could just work out what's the average colour value that's coming across in the capture area. And what is that? Is it red? You could just give it a name. And Adam says he has got some colour detect code for the M5 Stack product. Awesome. So M5 Stack, if anybody's not seen these before, these are quite neat. Interestingly, it does come with a Lego brick as well. I was intrigued to see that. So on the back of this M5 Stack, you've got like this Lego, and you can actually just plug the Lego in there. So you could add this to your own robot, which is quite neat. And I think inside it's an ESP chip, isn't it? Is it the ESP32? I've not actually taken this apart and had a look inside, but certainly an expressive chip. I don't think I've got this powered up, actually. I don't think I've plugged this in for quite a while, but yeah, these are quite neat. If you've not come across these before, they've got a whole bunch of connectors on them. It's got an SD card on there. It's got a nice colour screen. It's got 3 buttons on the front. And yeah, it's got a bunch of IOs, and the idea is like they're sort of stackable. That's the thing. They've got these little neodymium magnets in them. I think that's what they are, and everything sort of just stacks together. So they're pretty neat. I quite like them. So Adam said, even so, info. Yeah, if you don't like giving out your info, you're not going to get the commercial product for free, are you? Let's face it. So just check. Need to rewrite the code in my book. That's free on GitHub. Awesome. Drop us a link and we'll have a look at that. Maybe we need to do a show on M5 Stack. Adam, what do you think? Maybe you need to come on as a guest. So I think it's time to build the robot dog. Absolutely. Who's up for that? I've got a robot cat knocking about somewhere. I don't know where I put it, actually. I think it may be behind that box. Oh, it's just there, actually. Just there. But that's only got 1 degree of freedom as well in each of its limbs. But it's got 2 degrees, maybe. It's not got that Holy Grail 3 degrees for each limb. So Adam's saying for less info they give to social media and Microsoft or Apple, that's very true. So the kit you have on is $269 on Amazon or $329 on Lego. Man alive! So that's the actual kit I've got stood up there. I think it's called the 515. Just do that. So that's the kit number there, 51515, and you can see all the different robots they got on there. I mean, that one looks impressive because it's kind of stood up, but he's got two wheels there. He's a bit wobbly. That is the Jello one, which is basically just this, plus the head is some of the spare parts that weren't used on that. Then you've got one there that's got some wheels and steerable wheels at the front. Quite like this guy here that he's got like a little face, which is quite cute. Again, just two wheels and a tiny little marble thing that's holding it up. And then you've got one there that's a bit like a SMARS. It's got like the rangefinder at the front. I'll put this on the overhead and you might be able to see that a little bit easier. So yeah, that looks a bit more like a SMARS robot with the rangefinder on the front, but he's also, or maybe like a Vector, he's got like this ball thing there as well. Yeah, they're talking about the code, visual and text-based coding, and they've got, I mean, how practical is that on there? They've not got like the thing sliding up. Not very practical really there. So that's the, I was showing you something then you couldn't even see that. I was actually just showing you on the front of the box there, they've got like code and control, and they've got a mobile phone with the code on there. I don't really think that's viable in my opinion. So what else have we got on there? So Kushal says, great fan of SMARS from India. My SMARS runs on servos using the M5 stack. Awesome. I've seen quite a few. I think Adam's got a SMARS running on M5 stack as well. Next on one on the print bed with TT motors and M5 stack. Awesome. I'd like to see a picture of that. If you're not a member of the Small Robots group, Kushal, go to Facebook, search for Small Robots group. I think it's just group/Small Robots. And if you're not a member of that, join that and then tag me in it and send me a picture of what you built. I'd be really interested to see that. So Adam's saying I write a UI flow book, but because it's always growing, and it's free on GitHub. Adam, you have to drop us a link on that as well. So what's quite neat about these is you can build these apps using this AI flow tool and then upload it to that direct from the internet. It's quite neat. So in there's like a little guide for UI flow. So Adam's saying he's written a book all about that, which is pretty cool. And Kushal's there saying, good work, I've already seen it. I'm working on the integrated M5 stick with SMARS. Awesome. I also have the stick. So the stick is like a much smaller version, much smaller version. So there's the M5 stack and there's the M5 stick. I think this one has actually got some power on it. If I, how do you power this thing up? Give me a hint. Well, I did have this powered up a while ago. I think the batteries have probably gone flat on them. But yeah, that's really cool. I mean, on the back there's a whole load of different IOs. If I can hide my face. Look how awesome that is. It's got all kinds of stuff. And that's an ESP32 as well. Those things are just everywhere. Awesome. So Adam's saying, really cool. I take it the M5 stick 5 unit. Mine is still sat on the shelf. And I think that's an M5 stick 5, is it? Don't know. Awesome. And then behind me, you can also see I've got 3 other robots. So this is it the Lego Star Wars Boost? I think it's called. And what this has within it is, I don't know if this is going to come out very easily. I can't remember how you actually remove this now. But yeah, there's something to do with that, isn't it? This has a colour and rangefinder sensor, which is kind of all in one. If I just zoom in there, can you see that's got like a little colour module. Oops, it's trying to find my face there. Colour module, and it's got a rangefinder built in as well. So that's built into there. And there's this control thing which slides out. It's like a long, thin battery thing, and it's got 2 motors A and B on there. And you can take that out and then load that into these other robots so that it can go into the back of there and then make this robot walk. So this has everything it needs apart from the connectors to actually actuate it. And then there's this little the mouse one. I don't know what you actually call this robot from Star Wars, but it's got like a whole mechanism in here that when you turn it round, it it sort of moves. I don't know if I can actually get it to do that, but yeah, it basically makes these things flap up and flap down, and that flaps up and down as well. It's quite cool, but yeah, the actual robot is pretty cool. If I power that up, and if I can quickly get on the app on my phone, yeah, it's Boost, that's what it's called. Let's just jump back. Oh, I've done the wrong thing now. So there's like an app that you have to have on your phone to control this thing, but it's like there's a lot of story on it. Let's just turn that down. Yeah, it's like got a whole story thing going on there, and it takes ages to get to do anything. You have mission completes and all that kind of stuff, so it's very oriented towards that, but it's quite cool. That's a really cool robot. Maybe we'll have a look at that at another point as well. So Adam said colour versus colour. That's one of the few times the US version is better. Exactly. I think colour without the U looks a bit nice. I think colour with the U looks a bit French. Cyan is better. Sorry, he's used in print and is lighter than blue. That it's used in light. Ovi says nice. Hey Ovi, how you doing? How did people respond to your interview last week? Did that go down well? So Richard said Lego is a kid's toy. It's made to be tough and easy to manipulate, and the Mindstorms kit is aimed at kids. Also remember that the end cost is the retailer and tax. That's very true, retailer and tax, and that's one of the things with DIY robots. You generally pay a lot less for them, but they are a lot more delicate. I mean, this thing is not the same robustness, simply because it's not been designed for kids. There's very small components on there. You know, things wobble and don't quite sit, and if you turn it upside down, everything falls apart, and things are quite easy to break. Whereas these things have been engineered to be, you know, you can swallow that and it'll go right through you without doing you too much damage. You know, things that been designed that you can't swallow them by accident, and that's probably even got a hole in it just in case you do. Whereas obviously, yeah, you could probably swallow an M5 stick if you weren't careful. So what else? Tom says, by the way, there is a Lego comparable adapter for SMARS as well. Yes, there is. I was going to cover this actually. So that went out of copyright a long time ago, the actual design of Lego, and it's, I remember the measurements. It's something like 3 or 3.2 millimeters, like tall. The little blocks. I've not got any to hand to explain what I'm talking about. The little blocks, these little circular things, nubs, what would you call it? Those things, and the distance between them. You can't copyright that. It's just a physical feature. But you know, putting the word Lego across it, obviously they can copyright that. So you can 3D print your own. And there was an entire site, wasn't it, for quite a while, where you could basically reproduce with your 3D printer entire Lego sets. However, the time it takes to do that and the quality of the bricks that come out is not the same as buying an actual Lego brick. So, you know, you pay your money, you takes your choice, I think, with that. So SMARS and SMARS Quad, Adam was saying there. Yeah. Oh, stud. Yes, that's what it is. It's a stud. Of course it is. Yeah, I played every single Lego game that's out there on the Xbox 360 and Xbox One. And yeah, you have to collect studs. That's the currency in the game, isn't it? So, and you have to be careful. There are lots of copyrights, absolutely. So you can't say that it's Lego compatible. That's one of the things where Lego were taking people down on that. They would just, you have to call it like construction brick or generic construction block compatible, something like that. And everybody knows what you mean. And there was a big thing about it on, sorry, I'm just putting that together, on Thingiverse and Cult 3D and all the different 3D places. They basically, Lego took them down and said, you can't call things Lego. Lego is a trademark, so you can't have Lego thing, Lego component, Lego block, Lego SMARS. You have to just call it generic construction block compatible. So yeah, that's a bit of an issue there. But I've definitely got the, I don't think I printed any out yet, but on the SMARS Robot, where you have this thing that slides in the front here, this sort of connector, I've certainly designed one as well that has all the studs on the front, so you can plug in different Lego things. Now, there isn't actually much other area on the SMARS to actually put bits of Lego, but you could certainly put them on any other flat surface on the bottom, maybe on the sides, or maybe even on the tracks as well. That could be an area where we could have some studs just to be able to add stuff to it. I was wondering how popular that would be with people, whether they'd be keen in looking at more Lego and SMARS related stuff or Lego and robots related stuff. Whenever you search for Lego and robots, it does tend to take you to the Mindstorms stuff. But I still think that's quite limited, and it's just super expensive, and I don't know how far people take that in general. But I mean, when I grew up, I had a lot of Lego. I still have all my Lego in my loft. And there's a lot, but it's all like mixed together, and some of it is like 40 years old plus. So I might have to get that out at some point. So the big row with Lego that the plastic building blocks was a British invention that was never patented. Lego saw it and patented it and claimed ownership. Yeah, because it was called something else, wasn't it? I think Lego means play. Is it play something in Danish? Is it? I've not got Google to hand, so I'm not exactly sure, but I know it's one of those, is it Netherlands or is it Dutch? I'm not sure. But yeah, I know it's not a British invention. We did a lot of toy manufacture back in the day, but I don't think plastic blocks was one of the things we did. So yes. Cool. I can see Alex is on here as well. Hello, Alex. So yes, we once had a Minecraft server, and it was a private Minecraft server. We hadn't published anywhere that we had a Minecraft server available, and it was literally one of my servers. I've got 2 servers under my desk here that are not on, and we had a Minecraft server running on that. And this person just joined one day when we were playing, called Tamelio, and I've no idea how he found out that we had this Minecraft server going, so that was a very strange thing. So Alex is just talking about that, and he'd come onto our world and sort of mess with it, and we used to build all kinds of things in that. Minecraft is kind of like modern Lego, but in a virtual world, just not as extensible as Lego, perhaps. Cool, so that's everything that I wanted to show you today on the Mindstorms robots and how they stack up against the SMARS robot. And I'm very interested to see what you guys think about whether you want to see any more Lego content on there from robots' point of view, or extending our robots so that they can be Lego compatible. It's interesting that that's what M5 have done with theirs. They've made all their stuff Lego compatible as well. Yeah, so that's what I got for you today. Sorry I had a bit of a cold. It's getting better, so I should be able to be less disruptive next time with my drinks and my coughing and so on. So at least I don't have a cough attack during the show. So thanks for watching, and I shall see you next time. Thanks everybody. Bye for now.